Brett Roper is a golf partner of mine. That's not why we asked him to speak. You should see that guy hit a driver, though. Brett's currently the National Aquatic Monitoring Program Manager for the Forest Service and is an adjunct professor in the Watershed Sciences Department here at USU. He has a PhD in fisheries from the University of Idaho and a master's in forestry from USU. And he focuses his research on better understanding the relationship between land management actions, stream processes, and fisheries population dynamics. Brett?
So first of all, I want to thank the organizers for inviting me to speak here. I've been lucky enough to live most of my life in the West and a large part of that in the Great Basin. And you know, for people outside the Great Basin, when you look at it, there really doesn't appear that there's that much to be restored. I mean, certainly if you're driving across California. But that sort of belittles the fragility of the system. There's 140,000 square miles within the Great Basin. That's about 1.5% of North America. And within the Great Basin, about 1% of that is aquatic systems. And a large number of the fish in these aquatic systems are at risk. And so if you just look at the system, you don't really quite understand how fragile it is. And it's even more important to look back at the history to see how we got here. And that gives us some better understanding of how we might restore native fish populations. A quick outline of my talk. I'm going to give you a quick idea of the complexity of the aquatic biota and aquatic habitat within the Great Basin. Then I'm going to describe the risk aquatic species within the basin face and how they're distributed. And finally, discuss some restoration options for maintaining native aquatic species and their habitats. I think the first thing you need to recognize when you view the Great Basin from a fish perspective is it's not a single Great Basin. Depending upon how you count them, there's over 150 individual watersheds that drain to their own internal lake or playa. In general, the mountains within the Great Basin run north-south. On the west side, the mountains pick up the moisture. On the east side of those, there's a rain shadow effect. So there's a distribution of moisture even within the internal mountain basins. But beyond that, most of the large streams, as Jack alluded to at the last talk before this, actually come from either the west side in the Sierra Nevadas or the east side in the Wasatch Cache. So a lot of the larger stream systems actually come from the sides of the Great Basin rather than internal to it. So that's one point if you're trying to understand fisheries biology within the Great Basin. But perhaps even more is to understand the longer-term history. And as it relates to fish, that probably is best described in the period of about 10 to 40,000 years ago, late Pleistocene. At that time, there were a number of large pluvial lakes. And when I use the term pluvial, what I'm talking about is the elevation of the lake was determined by rainfall and snowmelt and evaporation versus some control feature in the system. And generally, that's divided into 5 large basins. Probably the best-known large fluvial lake is Lake Bonneville. It covered about 20,000 square miles, was up to 1,100 feet deep. Great Salt Lake's what's left of it. And also Lahontan Lake over here, which is about 8,500 square miles and up to 900 feet deep. But it's important to recognize that all these basins had large internal lakes in a period of 10 to 40,000 years ago. And if you start to look at the fish within this basin, these basins haven't always just been internally drained. For example, the Utah sucker is found both in the Bonneville system here, but also within the upper Snake Basin, which shows that historically these systems were hydrologically connected. The Railroad Valley springfish in the southern basin actually more resembles fish in the Colorado Basin than other portions of the Great Basin. And so that belies some connection historically between the southern basin and the Colorado River Basin. And finally, you have things like the Tui chub, which are primarily within the Lahontan Basin, but you can actually find a number of distinct subspecies along the whole west side of the Great Basin, which says that although they may be relatively recent unattached, that historically they were attached. So these lakes have disappeared over the last 10 to 40,000 years. So these systems have undergone a lot of natural change over a fairly short time period. But one of the things that this has done has led to the Great Basin being among the top 5 U.S. ecoregions for the number of endemic fish species because of that sort of rapid change. But because that change is already naturally fragmenting populations and letting there be and resulting in less habitat, it also is the second for the number of imperiled species. Just a quick rundown for what's in the Great Basin. There's 110 species, 23 fish, 85 mollusks, and 2 amphibians. In addition, there's 45 subspecies within the Great Basin. And then there's 36 different endemic forms, something that's the same species or subspecies but looks a little bit different than that same fish found somewhere else. So the classic example of a Great Basin fish is the Bonneville cutthroat trout that's in this region. If you went up Logan River, that'd be the most common trout, depending upon where you were, you would catch. The important part here is that most of the current and recent past range, sort of post-1850, was on the east side of historic Bonneville Lake. But what you see is that even now, even though it's been 150 years since Europeans have been inhabiting this, most of this range, which is the darker brown, no longer has Bonneville cutthroat trout in it. And additionally, a number of the remaining habitats don't have really strong populations. And I think the important part here is to understand this sort of north to south gradient. As you get further south, as there's less water, as there's warmer air, and there's more human needs or human competition for water, you see fewer and fewer of these Bonneville cutthroat trout hanging on. Very simple. Before I get there, historically there were 2 large lake systems these fish were still in. Utah Lake was a huge resource for Bonneville cutthroat trout. In the 1850s and 1860s, they were still commercially fishing for these Bonneville cutthroat in Utah Lake. Fish have all but disappeared from that lake now because of the water quality. And then you also have Bear Lake, which still has a large population of large Bonneville cutthroat trout. But even in this remote system, these fish face the pressures of an introduced competitor, the lake trout. A very similar story can be told for the Lahontan cutthroat trout. Basically, its relatively recent historic range was the remaining tributaries as Lake Lahontan reduced. Currently, the fish is primarily within headwaters tributaries. Historically, it was in Pyramid and Walker Lake. They're back there, but they actually went functionally extinct because water diversions, removing water. But there were the nice part of, you can argue whether they went functionally extinct, but between hatchery programs and the rest, they've been reestablished into those systems. And the important part here, when you look at these cutthroat trout, these are the adaptive fish. These are the fish that salmon that survive volcanoes. These are the adaptive fish. So what if you're not as adaptive? You can start looking at the large lake suckers, June sucker and the kiwi. So the June sucker is in Utah Lake and the kiwi is in Pyramid Lake. And these fish are long-lived, living up to 40 years. They spend most of their lives within the lake system, but they require a stream to spawn in. In both of these cases, as Jack was talking about earlier today, the stream systems feeding Pyramid Lake and Utah Lake have been so altered that at least at some point in the last 50 to 60 years, these fish haven't been able to make spawning runs. For all intents and purposes within Utah Lake, there's been no natural production of juveniles period, and even those that tend to make it swim into a lake that's now filled with a bunch of exotic predators, largemouth bass and whatnot. Pyramid Lake underwent sort of the same thing between 1905 and 1970, where a lot of irrigation dams were built, which diverted the water, resulting in sort of an impassable delta into Pyramid Lake. Water has been restored to that, but in both cases, if these fish didn't live 40 years, they probably would be extinct right now. The fact that they have a 40-year lifespan and can stay in these lakes without having streams, they probably would have been functionally extinct. And again, they're only found here, well, historically, they're only found here and here. And then we can move on to even a more unique group of fish, and those are the spring fish. As these lakes withdrew, a number of fish species found these small springs or small lakes, and then basically were stuck there as these lakes contracted. You've got the Borat Lake chub in southeast Oregon. You've got the least chub, now primarily along the border of western Utah, and then you've got Devil Hole's pupfish. And again, these are the habitat for these fish can be measured in meters at times, not in miles. So what's the trend for these species? Well, let's look at the y-axis on the left side. This is the cumulative number of species, subspecies, or endemic forms that have either gone extinct or suffered a major decline. And what you can see for the last 150 years is an increase in the number of declines and extinctions. Part of that can be explained by the taxonomic resolution that fish biologists have had. And so through time, we've actually identified more and more distinct taxa. So that's the y-axis on the right side. So we now know more and more fish are endemic. We've now identified more and more fish endemic to the Great Basin. But even within that period, you can see that the 1890s to 1900s, with the Transcontinental Railroad and mineral extraction, there was a pulse in extinctions and declines. Secondly, with the beginning of large-scale water diversions for agriculture, you can see a second blip. And then finally, you see a third blip in the 60s and 70s. At that time, there was large economic growth, but very little national regulation. You can see that basically that's flattened off for the last 30 years, and it's fairly easy to argue that between the Clean Water Act, the Endangered Species Act, and National Environmental Policy Act, that larger scale regulation is what caused that to flatten out. Because it's flattened out even though we've found more and more taxa. So I've quickly covered what the risks to these aquatic species are, but I'm going to quickly go back over them. And so when I talk about historic, those are the ones, they're historic and they're continuing. They're sort of long-running threats to fish within the basin. The biggest one of those is land management. You'll certainly hear it from me. I've seen it in most of the presentations. If you look at grazing, timber management, and the associated infrastructure such as road building or the removal of beavers to get water more efficiently down stream channels, that's had a huge effect on these fish populations. Second, you've got water projects, diversions, road culverts that keep fish from moving, and mosquito fish. But more recently, you're starting to see groundwater development and geothermal development. Certainly, climate change will have a big effect on these in the future, but there are other people who are talking about that, so I won't really get into that for here. Coming from a land management agency, and the fact that the land management agencies own about 70 or manage 70% of the lands within the Great Basin, it's pretty easy to put the blame, at least historically, on these agencies. I work for the Forest Service. Certainly the Forest Service has been the butt of many jokes through time. And certainly historically, I think that was well deserved. But certainly more recently, that doesn't play as well. To a large scale, between the Forest Service and the BLM and work with other people in Maggie Creek, that includes mining companies, livestock companies, and other state regulatory and management agencies, as well as Trout Unlimited. What you've seen is some serious improvement of native fish habitat. In this case, it's just passive. It's just the removal of cattle from a system. But we also, the Forest Service and BLM also put structures in to introduce rainbow trout from getting up, and they also remove structures to decrease fragmentation between populations. But even in that case, and I'm just going to quickly say that there's a dark cloud at times, and that's related to private property rights. So this comes from a recent court hearing or court case. Second, plaintiffs argued that the policies promoted by the Forest Service, including permitting the brush to overgrow the stream beds and allowing beaver to establish dams in the upper reaches of the streams, prevented plaintiffs from assessing and using water. So this rule was a ruling in favor of Hague, and it resulted in a $2.85 million award. And this was simply because the Forest Service was fencing riparian areas to keep the cattle from getting an established water right and increasing riparian vegetation growth, which increased transpiration, which reduced the amount of water in the stream. And so certainly these may have a big effect in the long term, because although public land ownership is 70%, water ownership in the basin is not at the same number. Private landowners own most of the water in the system. Secondly, if you want to go from restorations from these stream systems to these lake and stream systems where a lot of these lake suckers are found, it actually requires a multitude of activities. First of all, if you're looking at Utah Lake, there's some large-scale restoration activities such as Hobble Creek, where they hope to establish a stream where June suckers can spawn and produce viable young. Also, they're now starting to commercially fish Utah Lake. They're expecting to remove 6 million pounds of carp out of Utah Lake this fall, right now. One of the disadvantages about this, and Jack alluded to this earlier, these systems are so changed, the only way you're going to maintain that is to constantly put money into the system. Whether it be constantly bypassing water in the Truckee or constantly trying to improve habitat for June sucker, they're going to be a constant cost, and society's going to have to make a decision whether that's a good choice or not. And now to the easy restoration effort. So this is Borat Lake in southeast Oregon, where the Borat Lake chuck was. So in this case, it was almost completely surrounded by BLM. That was easy. The Nature Conservancy bought the 320 acres that was within that, which was the lake itself. And then Congress passed the Steens Mountain Act, which removed both mineral and geothermal from the table in this system. So in this case, for this spring fish, restoration was pretty straightforward. However, if you move to the southern part of the range, you don't see it being nearly as easy. So this is a graph of discharge from springs through time near Las Vegas. Las Vegas groundwater levels are down 30 to 60 meters. The two springs closest to Las Vegas, Mance and Las Vegas Spring, have now dried up. The fish that were in those systems are now gone. A good example of what can happen is in Fairbanks Spring. In the 1960s, they started to take spring flow out of this, and what you can see is a decline. They actually stopped it in the 80s, and what you see is that the spring flow comes back. So it shows that if you actually can reduce groundwater pumping, the spring flow will come back. The bigger question is these two, we're also in the area. In that case, what you're seeing is a 20-year decline just from groundwater pumping for agriculture and the rest. And so it's a pretty mixed message here. So what can we do for restoration in this case? Well, the simplest argument is at least get the water use by people in Las Vegas down close to other people in arid systems. So, just that would reduce the amount of water use by a third, from 600 down to 400 liters per day. And so if you could somehow restrain growth in this area, although it continues to be in the top fastest growing areas, just simple water conservation is probably the simplest of all solutions. But there's a bigger problem looming. The Los Angeles Water District has applied for about 150 groundwater permits. Those permits are scattered, and depending upon how much water they get and whose models you believe, they have the effect of they have the possibility of affecting spring flow ranging from the Mojave Desert in California to the Sevier River in Oregon. And so that's a huge thing out in the future. And so in conclusion, even though the Great Basin may look like, at least the people driving through it, it's fairly unaffected, there's a great many populations of aquatic species that are at risk. In general, stream and spring-dwelling species in the northern portion of the Great Regions probably can likely be maintained through standard restoration activities. That's either passive, protecting riparian system, or active, removing competing non-native species or blockages. However, I think that's pretty well known, is that the northern range is probably okay. As you move to these larger lake-dwelling fish, lake suckers, and these sort of adfluvial, the lake-dwelling trout, it's going to be a lot more likely on sort of continuous restoration efforts that seek to reconnect streams to lakes. But these are going to take a long-term funding commitment. And I get nervous anytime we talk about long-term funding commitments. And then finally, survival of spring developed biota living in the southern part of the Great Basin are not likely dependent upon on-the-grain restoration activities. Their survival will instead, a lot like Jack was talking about earlier, will be dependent upon legal decisions and political compromises. And that's it.
There's time for questions.
Brett, you showed springs near Vegas. How about through the northern part of the Great Basin? Are there fish populations there that have been disconnected? I know the spring use doesn't have as much pressure on it, but there's springs.
Yeah, to a large part, there are some springs, but most of them are further north. A lot of the spring-dwelling fish tend to be more in the Mojave, sort of south of. So most of the springs are further south. There are some, but I don't recollect exactly what the flows are doing.
I'm just curious, from the perspective of the Forest Service and other agencies that are dealing with the fish issues, how linked in are they to these permit processes, like LA wanting to take more water out of springs, near Las Vegas and so on? How linked are they to the processes in terms of putting some realistic limits on what they can do? Springs don't decline, for example, or streams perhaps don't dry up. Just through NEPA, just through ESA, or are you actually able to deal with this process?
For the most part, the southern part would be the BLM. I don't really know how involved they are, but generally we tend to stay out of those things and let the regulatory agencies stay more involved. As you all know, water is an extremely cantankerous issue within this region, and the Forest Service has enough without stirring water right issues into the.
Is that not effective, you think?
Huh?
Is that not effective?
I think if you look at what historically had happened in the leveling off of species decline within the Great Basin, I think it has. I think Clean Water Act, endangered species, and NEPA have really been effective at least leveling it off. It's going to be interesting to see how when we go into groundwater modeling, which is to me a much more difficult task if we continue to stay that way.